On these distance, rate, time problems, sometimes drawing a picture helps. So like it shows that going upstream, 205 kilometers, and that takes 5 hours. So you can say like distance equals rate times time. Let me undo that. Distance, try again. Distance equals rate times time. It's kind of the formula we're using. And then on the way back down, it goes a little bit farther, so we'll make that 295 kilometers. And we know it takes the same amount of time to go both ways. So this distance equals rate times time. So we could say 205 equals, I don't know what the rate is, but I know it takes 5 hours. So I just kind of filled it in. Distance equals rate times time. Solve for r here. Just divide by 5. Divide by 5. So r equals 41. And that would be what? Kilometers per hour. All right. So going downstream, it goes 295 in the same amount of time. What's the rate of both in still water, and what's the rate of the current? So let's do it the other way around. Distance equals rate times time. Again, 295 equals rate, and then the time again is 5 hours. And we'll solve this. Divide by 5. Divide by 5. So 5 goes into that. Rate equals 59. Okay? And that would be kilometers per hour. So if it's going against the current, it goes 41 kilometers per hour. If it goes with the current, it's 59 kilometers per hour. So the question is, how much is it helping and hurting? So if you look at 41 and 59 and kind of find how much different are they, if you take 59 minus 41, 59 minus 41 equals 18, and that would be, the difference is 18 kilometers per hour. And you just kind of think of that physically. The difference between going upstream and downstream is 18 kilometers per hour. Well, if you're going against, then it's going to obviously slow you, and if you're going with, it's going to help. So it kind of doubles that rate. So 18, if it's kind of halved, if we divide that by 2, equals 9 kilometers per hour. So let's think about that. So if we kind of say, all right, if I'm going, so that would give it a going, if it was in still water, you would actually gain 9 miles per hour, because that's how much it's fighting. So if we add those 9 miles onto 41, we'll be at 50 kilometers per hour. So that kind of makes sense. If I take away 9 from 59, it puts me at 50. If I add 9 to the 41, that is kind of like the equilibrium. So it's the halfway point between these two rates. So it says the rate of the boat in still water would be 50 kilometers per hour. The rate of the current is 9 kilometers per hour. So hope this helps. There's some maybe different ways, but this seems like the easiest. Just use distance equals rate times time. Find the two rates, find the difference, and have that, because half of it would be adding on, going one way, and it's subtracting the other way, but it's the same rate of the river going both ways. So hope that helps.